Everything around you, the star above you, the air you breathe, the water you drink, even you yourself, is made out of same fundamental building blocks, atoms. But how did we discover this invisible world? How did humans thousands of years ago even imagine something they could not see? Today we are going to travel through time to uncover the complete story of atom. We'll explore how human curiosity shaped science, philosophy and technology, from the earliest ideas to quantum physics. Welcome to STEM with the DK Swami, where we explore science, technology, engineering and mathematics in a simple, engaging and inspiring way. In this video, we'll dive into the history of the atom, from ancient Indian Greek philosophers to Dalton, Thomas, Rutherford, Bohr, and finally the quantum mechanical model of atom. By the end of this journey, you will be able to see atom is not just a concept of our textbook, it's the story of human curiosity and discovery. I'm DK Swami, a B.Tech graduate in mechanical engineering from IIT Ahmedabad, and I have been teaching physics for last 5 years to JEE and NEET aspirants. You can also explore more learning resources at my channel and website. Now let's begin the chapter 1. About 2500 years ago, Indian philosophers like Kanada and the other thinkers from the Vaisheshika school of the thought began exploring the fundamental nature of the matter. They proposed that if you kept dividing the matter into smaller and smaller parts, you would eventually reach a particle that could not be divided further. This indivisible particle was called the Anu. They also believed that these particles combined in different ways to form all objects and substances around us. Think about it, this was long before microscopes, before any laboratory experiments, just pure reasoning and observation of the world. This early idea of the atom was remarkable in its clarity and vision. It shows that the human curiosity has always sought to understand the building blocks of the nature, although it has a lot of incompetencies. Around the same period, in ancient Greece, Democritus and his teacher proposed the similar ideas. They called the smallest indivisible particle atomos, meaning uncuttable and indivisible. The atom word which we are using is something like that, isn't it? The Democritus imagined that the universe as made entirely of these particles, moving through empty space, combining and separating to create everything we see. It's fascinating to think that two completely different cultures, separated by thousands of kilometers, independently conceived the idea of the atom. However, at the time, these were philosophical ideas without any experimental proofs. Still, they laid the foundation of the scientific exploration of the matter. Fast forward to early 19th century, John Dalton, an English chemist, revealed and formalized the concept of the atom using the scientific experiments. Dalton proposed that all matter is made up of tiny indivisible particles called as atoms. Atoms of the same elements are identical in mass and the properties. Atoms of the different elements are different, and atoms combine in simple whole number ratios to form the compounds like H2O, where we have 2 water molecules and 1 oxygen. Dalton's work gave the chemistry a solid foundation, turning the atom from philosophy into measurable science. Yet, Dalton imagined that the atoms as tiny solid balls, simple and indivisible. We now know that the atoms are far more complex, containing subatomic particles like electrons, protons, and neutrons. In 1897, Thomson made a discovery that changed everything. Using the cathode ray tube, he found that the atoms contain tiny negatively charged particles called electrons. This proved that the atoms were not indivisible as Dalton and the other philosophers have believed. Thomson proposed that the atom is like plum pudding model. The atom was a positively charged sphere with electrons scattered throughout like raisins in a pudding. Although the model was later proven incorrect, it was the first step toward understanding the atom's internal structure. This discovery opened the door for a new era of atomic physics. Ernest Rutherford performed one of the famous experiments in the history of the physics, the gold foil experiment. He directed alpha particles, which are positively charged, at a tiny sheet of the gold foil. Most particles pass through the foil straight, but surprisingly, some bounced back at a large angles. From this, Rutherford concluded that most of the atom is empty space. There is a tiny dense positively charged nucleus at the center which contains almost all atom's mass. This replaced Thomson's plum pudding model with a planetary model where electrons orbit the nucleus like the planets around the sun. There were the limitations of the Rutherford's model. The classical physics predicted that the orbiting electrons should continuously emit energy as radiation. If that were true, electrons would spiral into the nucleus, causing the atom to collapse. And Rutherford could not explain the stability of the atoms or the discrete spectral lines of the hydrogen. Thus, while Rutherford's model revealed the nucleus, it left many questions unanswered, paving the way for Bohr. In 1913, Niels Bohr refined Rutherford's model by combining it with the idea of quantization from Planck. Bohr proposed that electrons move in a fixed circular orbits or the shell around the nucleus. Each orbit corresponds to a specific energy level. Electron can jump from one orbit to another by absorbing or emitting energy as light or photons. So with this, Bohr explained why atoms do not collapse, solving Rutherford's stability problem. Successfully described the hydrogen atom spectrum, including the Lymer-Balmer and Paschen series. Introduced the concept of the quantized energy level, a key idea in the modern theory. While there were limitations of Bohr's model, it could not explain the spectra of multi-electron atoms, treated electrons as tiny particles in the orbit, ignoring wave properties, could not fully incorporate the principles of quantum mechanics that were being developed in 1920s. In short, Bohr's model was a major step forward, but it was still an approximation, accurate only for the simple system like hydrogen. The quantum mechanical model emerged in 1920, solving the limitation of the Bohr's model. The key scientists who were involved for this were like Schrödinger, Heisenberg, and Max and Paul. The key ideas behind this atomic model are the electrons behave both as particle and wave, not just as tiny planets. Schrödinger developed the wave equation, described the probability of finding an electron in a certain region. These regions were called as orbitals. Heisenberg formulated the uncertainty principle, which stated that we cannot know the both exact position and momentum of an electron simultaneously. Why the quantum model is superior? Because it explained the behavior of multi-electron atoms, accounts for chemical bonding and the structure of the periodic table, predicts the atomic and subatomic phenomena with high accuracy. Instead of neat circular paths, electron exist in fuzzy cloud. Try to visualize this around the nucleus with the different shapes depending on their energy levels like s, p, d, f orbitals. Despite its success, the quantum model also reveals the strange quantitative nature of the reality. Electrons are not in a fixed path, they exist in probability until measured, highlighting the true complexity of the atomic world. From the ancient philosophy to the modern quantum mechanics, the story of the atom is a story of curiosity, experimentation, and discovery. Atoms are the building blocks of everything. The star above us, the technology we use, and even the biology we life. We have harnessed the atomic energy, explored the nuclear reaction, and developed the quantum technology. Yet the atom still falls mysteries from the subatomic particles to dark matter, and the journey of the discovery continues. This was the story of the atom. If you enjoyed, then please share with your friends so that you can get more stories of the science and techniques. I'm DK Swami. Explore more learning resources at our website or visit. I will see you in the next video. Until then,